This is Dr. Sirisha, working as Associate Professor in Institute of Aeronautical Engineering College. Today we are going to discuss about one of the most prominent sorting techniques, which is quicksort. A small animation on the same to give a brief overview on how quicksort works, followed by a Python code of the same. Let's have a look at what sorting is. Basically, sorting is nothing but arranging the data in either ascending or descending order. There are various types of sorting techniques like bubble, insertion, selection, quick, merge, heap, lots of and load more. These are the one which I have listed over here are the most prominent one. Here, quick and merge are the one which rely on divide and conquer technique. So here our point of concentration is quicksort. Quicksort is a sorting technique which divides the data, partitions the data into pieces and then unites them into a sorted list. So coming to this brief overview on quicksort, it is based upon divide and conquer as I have said. So based upon the pivot element. Pick an element as the pivot element. Pivot is nothing but an element which is of point of concentration. Now our agenda is by the end of each iteration, we have to place this pivot element in its right position. As if the list is sorted, if for the final list, whatever the list may be, the final sorted list, the right position of the pivot element is going to get. Right? So we can start or pick this pivot element from anywhere, whether our choice can be making the first element as the pivot element or the last element or the mid element or any random element. Any way you can start with, right? But if you have chosen, say if you have chosen that the first element will be the pivot element, in every iteration you have to use only the first element as the pivot element. You cannot change it in between. So decide guys. Okay. So this is the basic algorithm of quicksort. So choose one of the index as your pivot, the highest index value. So take two variables. So one is going to point to the left, the other is going to point to the right. So unless these two cross each other, right? Unless the left and right cross each other, you have to compare. So while the left is less than the pivot, move the left towards right. And once it crosses that, once this while loop breaks, start with the right pointer. If the right pointer is having a greater value than the pivot, shift towards left, right? And you are going to do these steps 5 and 6 recursively. So once you are done with these two, when the left and right crosses each other, swap the elements pointed by left and right. Okay, so if left is greater than or equal to right, so there is this is a point where you'll find the new pivot element. That means the pivot element with which you are working got the right position to use it. So for example, there are list of elements, a list of few elements are there. You have started with the first element as the pivot element and the second element as its left and the last element as its right. So by the end of the first iteration, the pivot element will find its right position. Thereby, this list will be divided into two halves. As the pivot got its right space, so the list will be divided into its left and as well as the right. Repeat the same process for the left side and the right side. Take the first element as the pivot element, hook the positions of left and right, and do the same process, right? Which I'm going to give you a demo of the same using animations. Have a look at this one. So initially, pivot is pointing to 5, the first index. Left is pointing to the next element, which is 3. And my right is pointing to the last element, 7. So let's start comparing. So as the value 3 is less than pivot, left is going to move. Once it finds an element which is greater than the pivot, it halts. Now it is the job of the rear to move, right? So rear is holding an element 7 which is greater than 5. That is the pivot element. So move it. The rear is going to get hurt only when it's find an element which is lesser than the pivot. So 2 is the right element, right? Right element over here. So once you reach over here, you have to swap the elements pointed by the left and right. So I hope you can see that 2 and 8. These two elements are swapped. Right? Now again, my left and right are fixed. They are not going to change. So now left is pointing to 1, which is an element lesser than the pivot. So move. Now my left is pointing to 4, which is lesser than 5. So again it is going to move. So now my left is pointing to 6, which is greater than pivot. So left halts. Now it is the time for right. The right is at 8, which is higher. So it is going to move. So, right. So this is the current scenario. Now swap the elements. Both are pointing to 6. They have come to the same position, right? So now as 6 is greater than right, make R move towards the left. So rear is going to come to an halt only, the right will come to an halt only when it finds an element which is lesser than the pivot. So 4 is such an element. So once you reach those positions, you have seen that left have crossed the right? So as they have crossed, now it's your time to bring the pivot element to its right position. So the place where they met is the right position, pivot element, and the element 4 comes to the front. Or these two elements, the elements pointed by the pivot and the left are swapped. Pivot and left are swapped. Now you can see that this whole list is divided into two halves. As 5 have come to its right position, I'm not going to touch it. So this is the left shell and the other is the right shell. Within the left and the right, we are going to conduct the same process by fixing the pivot left and right positions. Have a look at this one. Now pivot is pointing to the first element, which is 4. Left is pointing to the very next element of pivot, and rear is pointing to the highest index in the left sublist. Right? Coming to the right sublist, pivot is pointing to its lowest index value, which is 6. Then left is going to point to its next index value, which is pointing to 8, and rear is pointing to the highest index value where the element 7 is present. So repeat the same process recursively in these two halves, whereby at each and every level you are going to place the pivot in its right place, thereby dividing the list into two halves, which you can recursively work on to sort the list, right? So this is the end of the first iteration where 5 have come to its right position. Right? This one, I hope you understood what quicksort algorithm is basically. Right? Let's have a look at a Python code for the same. Okay, let's resume, guys. So this is a Python space shell where I'm going to write a code for quicksort. I'm taking an blank script where I'm going to write this code. let me first write a note saying that for what I have written this program, implementation of quicksort, right? So this is the implementation of the quicksort. So let me write the first of all the driver code where I'm going to get the maximum number of elements that I want to sort. I'm going to read them and I'm going to call that function, the quicksort function, right? So let's read the limits, guys. Say n be the variable which holds the total number of elements I'm supposed to sort. Int of input, enter the number of elements. So once let me close it properly, guys, because it is auto indented. Python is, I hope you know that. So then I'm going to read the list of elements, right? So let ARR be the list of elements that I'm supposed to read, right? So list map of int of input dot split. I'm using split function so that a separation comes, right? So I want to put a limit. I'm using a slicing operator so that I read only n elements. As soon as I complete reading n elements, the reading process will come to an end rather than going on and on and on. It will not halt, right? So I want to limit. I want to consider only the first n elements, right? Now I want to call the quicksort function. And what are the things I'm supposed to pass? Foremost is the array, which is holding the list of elements which I'm supposed to sort. The next is its basic index, which is 0, and the highest index, n minus 1. These are the elements or the parameters which I'm going to pass to the function. Then comes, once this is sorted list. Okay. I'm going to print the sorted list. Okay, guys. So this is my basic driver code. Now I would like to start my functions for quicksort. What it did, I have to repeatedly break. So taking the first element as the pivot element, finding the right position of the pivot element. So whenever I place it in its right position, my total list is going to broken down into two pieces, right? For that purpose, I can say that I'm partitioning them, right? So I'm write the same function, name it as the same partition, right? For this, I'm going to pass. I don't know what are their limits. So they are going to change, right? So as in the animation you have seen, the lower index of the right hand side got changed. Similarly, the higher index of the left hand side sublist got changed. So I'm using low and high as a generic terminology to specify or to point out the lowest index and the highest index of the current list. Can be a sublist or the complete list, whatever the case may be, right? So initially I'm going to give positions to my variables, which is I is going to hold a position low minus 1, whereas pivot is going to hold high. Guys, I have given a demonstration with the lowest index value as the pivot element. Now I'm writing the program taking the highest index value as the pivot element, so that you can understand both at a time. Okay, then for j in range of low to high. From lower to higher, I'm going to move my thread. If the element pointed by J is less than or equal to pivot, what will happen? If it is less than or equal to the pivot, increment I. Increment and swap the elements pointed by I and J. So in Python, it is quite easy to swap the elements. It's quite easy to swap the elements. A single statement will swap the elements pointed by I as well as J, right? So once this the low and high cross their paths, that means that is the end of the iteration. By the end of each and every iteration, I am going to swap the elements pointed by I plus 1 index and high. So the element pointed by the high and I plus 1 are swapped. High. These two are swapped, right? So the final value that I'm going to return is I plus 1. Right? So this is the basic partition function where I have taken the highest indexed value as my pivot element, and my lower is been fixed to I is fixed to lower minus 1, and high, as you know, this is the highest index value, and from lower to the higher, if the element present in my queue, in my list, is less than or equal to pivot, I'm going to increment the value of I, and I'm going to change or to swap the elements pointed by I and J. So once lower and higher cross their paths, when lower exceeds the value of higher, cross higher, then I'm going to swap the contents pointed by I plus 1 and the high, right? So this is how I'm going to partition them. Who is going to use this one? My quicksort function is going to use it. Let's write the quicksort function. So this quicksort function is going to take 3 parameters: the array, the lower index, and the higher index, right? So how I have to work? Unless my lower is less than high. If my lower is less than high, only I'm going to work, right? So I'm going to call that function with pivot element as the return value. Okay, the index value to pivot as the return value. So partition with the low and high as the parameters sent to it, right? So once they are sent, I have to recursively break it, right? So I'm going to recursively call this function, quicksort function, with the low, as I have divided, as the list is going to get broken into 2 halves. So, and the pivot element is at I plus 1, right? So now the list will be broken. Then I plus 1 value is going to come and set the return value of the partition function will be copied into the variable pi. So the element at pi is at its right position. So the list is divided into 2 halves in such a way that one is running from low to pi minus 1, and the right list will start from pi plus 1 to high. So recursively, I'm going to call the same from low to pi minus 1, and the same function call from pi plus 1 to high. recursively I'm going to call this until unless my lower is less than higher. For every lower is less than higher, I'm going to call this one, right? So with every call, it is going to invoke the partition, right? Once the partition is done, once the pivot, the low value and the higher indexes are pointed, I'm going to check until unless low crosses the high, I'm going to check the value of the jet index with the pivot. If it is less than or equal to, then I'm going to move I, that I'm going to move I index towards the right side by incrementing it and swapping the content pointed by I as well as J. So let's save this one with the name quick sort, right? So let's go through the things that we have written, my dears. So what we have done is we have written the driver code saying taking the maximum element of elements that we are going to sort. Then we have read a list of elements. Then I have called quick sorting technique, right? So to which I'm going to pass the array, its zeroth index, and n minus 1, which is its highest index. Okay, with that, the control will run to quicksort, which is the function definition, the basic logics definition, and it is going to check if lower is having a lesser value when compared to higher or not. If the condition prevails, then it will call partition function in return to break the list into two halves. Once the pivot element's right index value is found, I'm going to recursively call the left list and the right list of the partition, that is the pivot values, left and right two sublists, recursively into the same logic of partition, right? So I'm going to divide until unless I place each and every pivot element. With each iteration, I'm going to place the pivot element in its right position. So it is very easy to work with the quicksort. It is very less complex, right? So it gives you a feasibility, and you can take the leverage of having a pivot element of your wish. As I have given demonstration with an animation of taking the first element as the pivot element, and I have written the Python code taking the highest indexed value as the pivot element. Even guys, you can try taking the mid value as the pivot element, or even you can try any random value as the pivot element. But my advice will be, rather than going for mid or any random value, choose one of the higher or lower index values to be your basic pivot element. And you can see that it is a recursive function. It is a recursive function. It is a recursive function. It calls itself. So once this is done, let's run this program, guys. Okay, let me take a list, say 6, with the maximum size of it, and the random values are 4, 3, 5, 8, 7, and 9. And the sorted list is 3, 4, 5, 7, 8, 9. Right? So this is how we are going to sort the elements using a quick sort. Right? So have a look at the code, guys. It's quite easy, very simple to implement, and it is recursive. Let me execute it once again for your sake. Let me take 9 elements now, starting with 6, 5, 7, 0, 3, 5. I have to take repeat elements. 4, then 8, 11, 10. Right? So This is the sorted list 0, 1, 3, 4, 5, 6, 7, 8, 11. Right? So this is a demo of quicksort. And guys, I hope you understood the logic of quicksort and implementation of the same. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.